Hi everyone, this is Junyuan Su. My topic is tidal power generation potential in Bay of Fundy. And to start the topic, let's have a look at where is the Bay of Fundy. The Bay of Fundy is a bay between the Canadian provinces of New Brunswick and Nova Scotia. With a small portion touching the US state of Maine, it has an extremely high tidal range. The Bay of Fundy lies in a rift valley called the Fundy Basin. As the rift began to separate from mainland North America, volcanic activity occurred, forming volcanoes and flood basalts. These flood basalts poured out over the landscape, covering much of southern Nova Scotia. Sections of flood basalts have been eroded away, but still form a basaltic mountain range known as North Mountain. As a result, much of the basin floor is made of dialectic basalts, giving its brown color. The Rift Valley eventually failed as the Mid-Atlantic Ridge continued to separate North America, Europe, and Africa. Tide is generated by the gravitational attraction of the ocean water to the moon. The Bay of Fundy has the largest tidal range in the world. It also has the highest tides in the world. In the open ocean, tides typically have ranges of 1 to 2 meters. However, the difference between high and low tide can be over 60 meters in the Bay of Fundy. The water level of 21.6 meters resulted from the combination of high winds, extremely low atmospheric pressure, and a spring tide. The tides in the Bay of Fundy are semi-diurnal, which means that they have two highs and two lows each day. The height that the water rises and falls to each day during these tides are basically equal. There are approximately 6 hours and 30 minutes between each high and low tide. The large tidal amplitudes in this region are driven by the near resonance of the Bay of Fundy, which is the goal of main system. In the Bay of Fundy, we can also see a phenomenon called tidal bore. It only happens at places with a large tidal range, where incoming tides are funneled into a shallow, narrowing river or lake via a large bay. The funnel shape of the Bay of Fundy also increases the height of the tide. As a result of the high tidal height and the large tidal range in the Bay of Fundy, it creates a significant amount of potential energy and kinetic energy every day. But how can we use this energy? Tidal energy harnesses the movement of ocean water to generate electricity through a number of mechanisms. But first, let me introduce an organization. The Fundy Ocean Research Center for Energy, which is also known as FORCE, is Canada's leading research center for in-stream tidal range, located in the Bay of Fundy, Nova Scotia. FORCE is acting as a host to technology developers, providing the electrical infrastructures to deliver power to the grid. FORCE also oversees and independently reviewed environmental monitoring in the Minas Passage. FORCE also conducts research to better understand the site conditions, estimated to contain 2,500 megawatts of extractable power. FORCE is a catalyst to the safe development of this new clean energy technology, with the potential to deliver renewable energy for generations to come. On a flood tide, 160 billion tons of seawater flows into the Bay of Fundy. This is more than 4 times the estimated combined flow of all the world's freshwater rivers during the same 6-hour interval. The tidal currents in the Bay of Fundy are fast, over 18 kilometers per hour at peak surface speed. There is more than 7,000 megawatts of potential in the Minas Passage, 2,500 megawatts of which can be extracted without significant effect on the peak tide height. Models indicate upwards of 50,000 megawatts of energy exist in the entire Bay of Fundy. Energy can be harnessed from the tides in two ways, which is the potential energy and kinetic energy. Potential energy is using the change in height of the tides, and kinetic energy is using the flow of the water. Tidal power is very sensitive to speed. The power output varies the cube of the speed. In other words, if the water flows twice as fast, it makes 8 times the power. Also, tidal turbines do not have to spin as fast as windmills to generate power, because water is roughly 800 times more dense than air. Tidal power technology is constantly evolving. However, the most common technology today can be classified into 3 main categories, which is in-stream devices, barrages, and tidal lagoons. In-stream devices make use of the kinetic energy of moving water to power turbines in a similar way as windmills using moving air. This method is gaining in popularity because it is removable. It can be scaled up gradually and has lower potential cost and ecological impact. Barrages make use of the potential energy in difference in height or head between low and high tides. They are essentially dams across the full width of a tidal range or mouth of a river that has a free-flowing connection to the ocean. Barrages have very high costs, a worldwide shortage of viable sites, and associated environmental concerns. Tidal lagoons are similar to barrages, but can be constructed as self-contained structures, not extending fully across an estuary. Some suggest that this may reduce both cost and overall impacts. They can be configured to generate continuously, which is not the case with barrages. The in-stream tidal turbines, test at force, use the flow of water as the source of power. Each of the turbine is designed to use the flow of the passing water to turn an impeller, just like a windmill. Each turbine is different in how it manages this. Designed to operate in the open flow of water in the Minas Passage, the turbines have to operate in a range of water speeds, from 0 to a maximum of 10 knots. As water speeds can vary from the surface to the seafloor, test conditions for each turbine will differ slightly and depend on both the site location and the depth at which they are positioned. The Clean Energy Fund awarded Force $23 million to design and build onshore and offshore infrastructures, as well as for the development of Fundy Advanced Sensor Technology, which is a research program to build recoverable instrument platforms designed to monitor and apply the foresight. In conclusion, tidal energy is more reliable and more predictable than wind power. It makes the Bay of Fundy one of the greatest sources of tidal energy on the planet. Nova Scotia is a province still largely dependent on burning coal for electricity. The tidal energy in the Bay of Fundy alone could supply green energy that is enough to satisfy all of Nova Scotia's power needs. However, the in-stream devices are still not reliable when facing extreme weathers, and in order to obtain sustainable development, force should pay more attention to the local biosphere. And this is everything. Thank you for watching.